All right, thank you for being here. I think this is very exciting time in the industry today with what's happening with technology. And as an MD, we are, innovate a startup. We started our journey about 4 or 5 years back with tremendous shift in technology, what we're delivering to the world. While we are a startup from that perspective, but we are a 50-year-old company, right? So we have the agility of a startup, but the strength and muscle of an enterprise, right? And what we have done over the period of last few years is really change the landscape of technology in terms of what we offer, right? Let me, before I do that, let me invite my colleague, John Stewart, on the stage as well. What we are going to do today is we just give you a brief about what we have done from architecture perspective in terms of high performance computing, how we are better, how we are partnering with partners like AWS and others as well. And then we will also have, we'll have John sharing a lot of his perspective around, his experience in the industry, 15, 20 years plus experience in solutions and architecturing and engineering as well. And then we'll have, once we've spoken about this, we'll have one of our partner come in, speak about how some of the solutions that they are providing to the customer and how they are leveraging cloud and AMD technology to help you from that perspective, right? So, John, welcome, and over to you. Introduce yourself, and I'll probably take it up from there.
I liked how you positioned AMD as a startup, and it's interesting. So, my previous role is with Intel. I was with Intel for almost 30 years, and like Sanjeev said, I've been in this enterprise space, for many, many years, managing teams, calling on enterprise customers, right? It's interesting that you say startup, at Intel, big company, but I have noticed since I've come over to AMD, it's a breath of fresh air. It really is. It's a very nimble company. They're executing. I shouldn't say they anymore. So I've only been with AMD for about a month, just to be candid, right? And AMD is executing like crazy. And I saw this from the other side of the coin when I was at Intel. So I'm actually in the business unit here at AMD. I just joined about a month ago, and I'm the director of cloud solutions. And that's really going to be the overarching theme of the day, is talking about solutions and workloads, in the cloud, and the importance of looking at the actual solution, looking at how to optimize that solution, because all workloads and solutions are different, right? They have different bottlenecks, right? And they have different requirements from an infrastructure perspective. So, one of my key messages that I'll get out right away, but I'm going to hit it over and over again, is, matching the right workload with the right instance family, type, and shape, right, is critical to delivering the maximum performance, lowest cost, lowest carbon footprint, et cetera. So I love this startup. It's really fun being here, Sanjeev.
Absolutely.
And it's a great company. Like I said, my perspective has been, on the other side, and trying to compete against AMD, and and we'll talk more about the processor technology and the various generations, right, that are now in AWS. But anyway, back over to you.
So we are in the third generation, right? So it's not that we are new. We are in third generation already. The great part about our organization is we have phenomenal roadmap, and we are executing to that. We'll be launching our fourth generation very soon, end of this year. We'll be leveraging our fifth generation, launching our fifth generation sometime next year as well. So roadmap is very clear, and every generation is not just about changing some specs and frills, but we enhance our security story. We enhance our IPC uplift to 19, 20, 25%. And when you see this deployed in the cloud as well, you are actually, when you move your workload, you are going to get a better performance, enhancements on the performance as well, right? So third generation, and it goes up to 64 core on a single socket. So really look at it from perspective that it's dollar per core, right? And we'll come to dollar, performance per watt story as well. So it's not about just we are delivering performance, but delivering at much lower wattage as well. So we all together are supporting the sustainability story as well, right? So maybe quick thoughts from your side on this, John.
Yeah, you said it well, Sanjeev. The EPIC architecture is such that, I believe it allows, the ability for AMD to actually execute and get the next generation out the door. I don't know if you've been following Intel or not, but we've been struggling with getting our latest product out the door, their product out the door. But the EPIC architecture is such that you can add chiplets, right? So basically you add 8 cores, 8 cores, 8 cores, and they're all tied together with an infinity fabric. And the generation out now, which is the 3rd generation, right? It started with Naples, and then 2nd generation was Rome, and then now 3rd generation is Milan. And as you mentioned, 4th generation is right around the corner. And as I've joined AMD, this has blown me away, actually, about this next generation Genoa, Bergamo coming up. I mean, the number of cores that AMD is going to be adding, right, and having AWS incorporate into their cloud so that everyone can take advantage of that it's really fascinating. And so, like I was saying earlier, Sanjeev, this is a great marketing slide. Extending per socket, per core, performance leadership, world's highest. But I got to tell you, hands-on experience against this, right? This stuff is real. It's real. So again, back to my last role at Intel, I hired a global team of cloud solution architects, into Intel. First time we had ever brought that role into Intel, and these cloud architects would come from the GSIs. I see my good friend Suresh back there with HCL. But a lot of my team were coming from Accenture and Avanade and Cognizant and HCL, even from the hyperscalers. And it was really interesting as I brought this team into Intel. The first thing I did was I gave them a workload to go run on the cloud, get hands-on immediately, and then go experiment, right? Go see how it runs on the latest Intel, how it performs against the previous gen, and also how it performs against the competition. And my team actually pushed back on me because they're like, John, why do we need to do this? It doesn't matter. The instance doesn't matter, right? They were architecting cloud, and there may be many in the room here that have that perspective as well, that the instance type, choosing the instance, doesn't really matter, And in fact, a lot of the salespeople at Intel were not being invited into a lot of the customer conversations because they were saying, why do we need Intel at the table, right? What do you guys bring? Right? We're already talking to AWS, that's all we need. And so I had to kind of, bust through that. And what we did was when I brought this new team on was that we would get hands-on, we'd run databases, we run transactional databases, NoSQL databases, we did big data, we did machine learning, right? We did data ingest, we did VDI, we did HPC, right? So we started looking at just a broad variety of workloads, right? And what we discovered was, in fact, choosing the right instance type and shape, right? For that workload, it brought tremendous, significant amounts of additional performance and lowered your cost. And also we started to look at how we could lower carbon footprint. So my main point here is that it absolutely matters in terms of how you select the instance for the workload, how you optimize the workload. We actually went right into the machine image, right? And we would make sure that the kernel optimizations were there, all the application code, libraries, config files, flag settings, all these things were very mundane. But if you can package all that up into a recipe and land it on the right instance type and shape, you get unbelievable more performance, lower cost, better performance per watt, and that's what we're building at AMD right now. So I'm actually, in the engineering team, working on a wide variety of workloads. We're discovering, right, how to best configure that for AMD architecture, and it is, a little bit. Although it's x86, and code ports over very well. The underlying architecture does have some nuances, right? So that's why it's important, to work with us to take our recipes that optimized for the AMD instances so you can actually get that best class performance and lowest
Absolutely.
cost.
And on the sustainability, right, what we deliver as performance, for example, for the performance that needs to be delivered, uh, somebody needs 450 watt power. We deliver same performance at 280 watts, right? I'll give an example of the world's fastest supercomputer, which is Frontier. I would really encourage you to read about it. It's built by HPE Cray based on AMD CPU, AMD GPUs, 7,900 odd CPUs, 38,000 plus GPUs, the first one to cross the exascale, right? And it is twice fastest than the next one and twice fastest than the next 7 put together. And giving that performance at 50% of the power consumption. That's the kind of architectural difference we are bringing to the world. Sustainability is very key at AMD. We are looking at reducing carbon footprint as we go from generation to generation perspective. The other aspect we'll touch upon a little later is security, which is at it's our DNA. It's not an afterthought. It's at our DNA. So we'll talk about that as well. But sustainability is very important. And today when we see these hyperscalers scaling up, the cloud providers, CSP scaling up, it's very important that every wattage that gets saved matters, and it translates into in a way a TCO for you as well, right, as a customer, right, or as a partner when you're doing that part. So all these things, combination of that comes into the sustainability story.
This is I'm sure it resonates with everybody here. As I go talk to customers and partners around the globe, sustainability is coming up more and more often. In fact, oftentimes it leads the discussion. How can you, contribute to my sustainability program, right? And Sanjeev said it well, right? Again, I'll go back to the underlying architecture. So performance per watt is a design point that's actually baked into the EPYC architecture at AMD, right? Which is not always true with the competition, right? And so the engineers, and I've seen it with Genoa and in the future, and they're like, we are going to design for the lowest power envelope, right? And so it's by design that it's a lower power part, right? And then when you bring it into the cloud, and then you get back to that story I was talking about earlier. If you optimize the workload, for the right instance type and shape, you can complete that work quicker, shut the instances down, save power. You can also, if you optimize correctly, you can actually run on fewer vCPUs. Thereby saving power, also saving cost, right? So power and cost are almost two sides of the same coin here, right? If you can actually get a better performing image, right, you can actually save cost, save power. You can save cost by running on fewer vCPUs, so you're saving cost in the cloud. But if you're running an application that's licensed by the core or the vCPU, you're going to save tremendous amounts of money by reducing your footprint in the cloud, right? And we showed customers how they could, for instance, Microsoft SQL Server, right, is probably the most widely used database, and that's moving from on-prem to the cloud, right? It's going out of service. And we found that if we gave a very optimized recipe for SQL Server, in fact, it's not memory bound, it's storage bound. So you actually have to add IOPS, you have to add NVMe drives, right? Because it's writing out log files and tempdb files, and while it's doing that, the processor is idle, right? So you're not getting that. But if you relieve the bottlenecks, which is what we did, and you give that recipe, now you can actually have maximum performance, pay a little bit more, or you can keep performance the same, and you can reduce your footprint, right? You can run on significantly fewer vCPU, and again, saving cloud computing costs, but also licensing costs. And we showed a bank in Germany how they could save hundreds and thousands of euros just by moving to this optimized recipe for SQL Server, thereby saving them costs. So, and it's the same thing for power as well, right? Again, if you run on fewer vCPU, you can complete the job quicker, right? That's all going to contribute to a lower carbon footprint, and that's going to contribute to your overall sustainability message. So we can be a big part of that sustainability message.
And just to, since you mentioned engineering, I can't refrain myself from saying this, but super proud. We have 5,000 plus engineers sitting here in India and Bangalore and Hyderabad who's designed this Zen architecture, which has been leveraged by the world. So as Indian, it makes me super proud that, we have contributed that to the world and it's been leveraged across the globe. So, and we have those resources available if there are any areas where you need support leveraging our technology. If you're facing any challenge on any of these technology, we have resources in country who can really help from that perspective, right? So I think kudos to the engineer sitting here and who's delivered that to you. So super happy with that. Briefly about on the, the epic benefits on the cloud, right? One is leverage savings to accelerate growth. How many of you use, I'm sure most of us here use AWS, right? But look at, AMD powered instances, we offer 45% better TCO compared to equivalent from competition. So a serious look in terms of why you should really be considering from TCO perspective. Every dollar saved is a saving.
I don't know if everybody caught that or not, but this is an amazing point that I discovered here. I mean, if you look globally, AMD instances are typically 10, 15% lower than the competition. But here in India, in the Mumbai data center with AWS, it's 45% lower. I mean, it's crazy. The cost difference of moving to AMD in the Mumbai AWS data center, I mean, it's incredible value. Did I say that right? Yeah.
John, one of the questions that typically comes from a lot of people, not only here but otherwise, and we address that question is, how easy is it to migrate?
Yes.
Right?
Yeah.
Historically, people have been using, and they say, what do I need to do? Oh, I'll have to put in a lot of effort to migrate. So your thoughts around, migrating, and especially when we are talking about the TCO benefits, what's your views on the ease of migration that we offer?
Yeah, well, fortunately, right, AMD architecture is x86 compatible. So if you're running on the other 86 architecture Intel, right, the code just comes over. We always encourage to test right before you actually move a workload into production, but it should just move right over. The Nitro hypervisor is used for both the Intel instances and the AMD instances, so there's a lot of compatibility there. So it's very easy. It's very easy just to move. Now, I did want to say a little bit more about migration because I want to get you guys even more savings, right, than the 45% by just coming over to AMD. And right, this goes back to the workload optimizations, right? And so when we start looking at how we optimize the actual workload, this is where we discovered that a lot of the partners, right, and customers are starting to use tooling, using FinOps tools to make instance recommendations. They're using automation to actually deploy workloads, whether it's a Linux workload or a Windows workload. They're starting to move towards a DevOps approach, CI/CD pipelines, and using what's called infrastructure as code. So, when you manually spin up instances and you try to configure workloads, that's prone to error, right? So cloud deployment models are rapidly moving towards automation. And what we've seen by looking at a lot of the global systems integrators, the MSPs, and customers alike is that they're moving towards a pretty common set of tools. So we see Terraform come up a lot in terms of infrastructure as code, actually laying out the landing zone. And then for actually configuring a Linux machine image, they're using Ansible, using PowerShell scripts for Windows images. So we're mirroring that at AMD. So in the engineering group, we're running just a plethora of workloads using those tools. So everything's on Git. We're using Terraform, Ansible, PowerShell to actually run all of our benchmarking and optimizations, and we're willing to share those codes, with you, as you are on your journey towards automation, right? Because this is really the right way to deploy on the cloud, and we're seeing a a lot of demand for working with us to actually take these optimized recipes, bake them into the Terraform, into the Ansible, even ingesting this data into a FinOps tool or a cloud management tool so that those tools can make better, more intelligent recommendations on which instances to land on. So these are all the things that we've learned, and it's interesting when you do it manually and you don't have all the data available to you. I've seen that typically the instance chosen is wrong, right? So I see a lot of customers leaving performance and cost on the table because they didn't have all the information and all the tools to actually deploy and choose and deploy on the right instance type. So migration it's easy, it really is. You can just move right over, but if you want to get that extra out of it, which I want to deliver, right? This is where you start looking at how you deliver, right? And again, this goes to the automation.
Yeah,
so.
and I remember one of the video from a very senior solution architect in AWS worldwide, and I'll not mention the exact number, but he talks about a single digit time it takes to migrate from one to another one, right? So it's that easy. And please look out for, I think his name is also John, if I'm not mistaken, but that's the kind of speed at which you can actually migrate and leverage the benefits, right? And what's happening is that some of these architecture that we are designed is designed for modern workloads, right? You see a lot of these SaaS players who build up technology today for it to, and needs a different technology. We're building more cache. We're building, against a 92 MB, we'll go up to 192 MB on a cache. So you building up an architecture in the processor which makes more sense, right? Which helps the application workloads to perform much better, right? And next we really want to talk about is the security aspect, right? We have sorry, I don't want to steal your thunder, but
no.
Maybe a couple of points on that. We have a processor within our processor, and it's a hardware-based encryption that we do. So let's take, for example, VMware. They uses our technology from vSphere 7 upwards, where the VMs are encrypted with a 509 keys. So even in a physical socket that you have, each 4 individual CPUs can be encrypted, so they can't speak to one another. It's called secured encrypted virtualization. This technology is being used by hyperscalers. You would probably have heard about confidential computing. That's based on AMD technology at the back end, right? So a lot of these partners are leveraging, building up solutions which helps. And we all know how important is data security today. If you look at corporate, they are talking about, it's a board level discussion. No more a CIO or CIO's decision, right? A CEO talks about data security. Data security of their own data of their customers as well, right? So leveraging some of these technology really helps you to make sure that their data at rest, data in use, or data in transit is completely secured, right? So it's a phenomenal story for you to leverage in your environment, or build up solutions around that space in whatever work vertical or the workload that you are building on, right? So just wanted to give that point.
So yeah, again, a really important topic here, particularly in public sector. As I go and talk to public sector, governments, whatever it is, they're very have very sensitive data. And a lot of public sector hesitates, right, to move this data into the cloud. So how we work with AWS, is very important. So Sanjeev was describing the SEV, right? So that's the whole notion of you can actually encrypt the entire VM. So you're encrypting disks, memory, everything in that VM. The other technology is you can actually just encrypt the memory. I forget what that acronym is called, but you can just encrypt the memory.
Yeah, secured memory encryption.
Secure memory encryption. And in fact, this is what AWS is using. So AWS actually, I referenced Nitro earlier, right? So Nitro actually brings a lot of, it does a lot of hypervisor offload, right? But it also does security. So the Nitro card actually has a security chip in there that actually can do VM isolation. So the AMD architecture works in conjunction with the Nitro architecture, and we add the additional level of protection where we can actually encrypt the memory. So that's how we would work with AWS. So great solution. It's something that you could take out to the public sector. Well, I guess this is public sector audience here, right? So I think this would be really interesting to do some pilots around this to see if this would actually meet the requirements that you have for bringing this type of data onto the cloud. But yeah, incredibly important area. Like I said, security, sustainability, right? These are all, and then of course you've got your bread and butter, performance and cost, right? But these are the 4 vectors that we try to optimize against, right, in order to bring real value to the customer.
Yeah. So coming to the adoption of this, we were 0 in 2020. Today we have more than 750 plus instances across hyperscalers, and AWS has been a very, very early adopter in terms of leveraging our technology. The confidence that we get by our hyperscalers like AWS leveraging generation to generation our technology is a massive testimony about what we are delivering, right? It's not that, nobody would invest time, money, resources to build up something where they are not sure that it's going to be there today or there tomorrow, right? We have a fantastic roadmap, as we mentioned earlier. Next 3 generations already been announced with timelines, and we have delivered to that, right? So if you look at what we have from on EC2 with AWS, is the general purpose, the memory optimized, we have compute optimized, we have spiky workloads, we have for HPC, and we have for accelerators as well. I'll briefly talk about accelerator before, John, you speak about the other ones. Accelerators are, we acquired a company called Xilinx. It was a $50 billion acquisition that we did this year. And this is, so we are the only company now that has got CPU, GPU, as well as adaptive computing. So we have our Xilinx powered instances available. One of the workload that can really work would be, just give an example, video transcoding, for example, right? So a lot of these OTT players leverage some of these technology as well. So we have that also as an offering within AWS as well. So if you have any of these applications, please do look out for that, right? And while he speaks more about this, a simple way to look at differentiator between competition is this A stands for AMD. Right? So if you're selecting an instance on EC2, AWS simple monthly calculator, select and see the options. You pick up C5 or you pick up C5A, and then you will see the cost difference, right? We have a booth where we're kind of showing that to you. Have a look at and you will see yourself the advantage that you can get from that perspective. Right?
The other decode is the 6. The 6 corresponds to our EPYC 3, right? So the 6 is Milan, and those are the new ones that have come out. And then the 5 is the Rome. So, and then of course, like Sanjeev said, the A denotes AMD. So. Yes, you can see the explosion of instance types and shapes. And this goes back to my earlier point, right? The more instance, families and types and shapes that you have, the more complex it gets, because like what I said earlier, if you choose the right instance family shape and marry it with the workload, this is how you get the best performance and lowest cost, lowest carbon footprint. So as this, and it's a good problem to have, right? As we get more and more instances available on AWS, right, this gives you the flexibility to really hone in on that amazing performance and lower cost. And this is where we can help you. We're going to give you recipes. We're going to, like I said earlier, we're going to try to bake a lot of this information into the tooling, right, so that a lot of this will happen, in an automated fashion. But yeah, this is a great problem to have. Sanjeev said it great over here too. I mean, different workloads. I mean, video transcode. We're seeing a lot of demand for this. And I think we're actually, so the Xilinx, I think there's actually another instance in here, like the G4AD, I think. So we actually have the graphics chip in there, so you can run VDI, and
that's right.
So again, matching the workload to the instance family, right, is critical, right? And then getting the right shape, right? Does it scale out vCPU? Does it scale up? Is the bandwidth in storage or is it in memory? All these things really matter in terms of, again, getting that best performance, lowest cost. So, yeah.
How many of you were there in Sunil's presentation probably yesterday? Not many of you, but I'm sure all of us know Aragya Setu, right? We all know CoWIN, right? We all know DigiLocker, all on AWS, all on AMD, right? That's the power scale that's been, the confidence that's been built up, right? And nothing bigger than Aragya Setu or CoWIN. We are a country of 1.38 billion people. I'm pretty much sure 100% of them have used this, either CoWIN or this, and that being leveraged at that scale and forward with AMD is a massive testimony of the confidence that not only the government of India, but our technology partners who did this has on what we have to deliver. So I don't think there's anything bigger than probably these two massive applications or workloads or the solution that we can speak about, right? And there are more. There are many, many more that we are hearing. Not all that we can really talk about. But since these two were mentioned yesterday, I took the liberty of doing that part. But yeah, that's a fact. So you can be a tremendous confidence in terms of leveraging our technology with AWS, right? Okay, some of these instances, like he mentioned about G480, so we'll not really skip there on this multimedia, as we say, right? The C6A high performance computing with our third generation, and that's available very much here. And then the general purpose, right? So, John, maybe your thoughts around broadly using the M6A or with Milan on the broadly the general purpose workloads.
Yeah. So again, these last three slides really it reemphasizes our point around workload, getting that right workload on the right instance, and in fact it spans all the way out to critical ISVs, like our next speaker. I hope we still have time to bring him up here, where we're going to talk about a really interesting application and use case, right, and more in the kind of in the IoT space, right, big data ingestion, analytics, things like that, right, and using AMD. So yeah, I mean, again, I feel like I'm repeating myself a little bit here, but choosing that right instance family, right, and the general purpose here is the workhorse, right, the M and the C. We just recently launched the R6A on AWS. That's memory optimized, but really the workhorse are these instances, and we can run any number of databases here. Databases are all rapidly moving to the cloud, whether it's a licensed database like SQL Server or Oracle. Oh my God, the whole SAP migration to the cloud, we're not there in HANA yet, but the whole SAP landscape runs fantastic on AMD, right? Great price performance, right? But other than the transactional databases, all the NoSQL, so Mongo, Cassandra, Redis, we're doing a lot of work with Redis right now to optimize Redis on the M and the C. Actually, we're looking at see how it runs on the R as well. But then you go right into data analytics, and then you go right into machine learning. How can we configure those instances to run those classic machine learning like XGBoost or scikit-learn, or even into deep learning with PyTorch and TensorFlow. So these require some optimizations in terms of libraries to take advantage of the underlying architecture. But yeah, there's all kinds of workloads that you can run, on these general purpose and compute optimized.
Just to add on, the HPC part of it, right? You look at HPC, I think we are undisputed in terms of the performance that we deliver, right? We have customers who have on-prem HPC with us for research, oil and gas, and various applications. We have same customers also using cloud for HPC as well, right? So, almost 90% of them is with us. So we're a very, very large scale HPC, and that's been the mantra for our CEO. We want to be in HPC, high performance computing, not just means as an application, but whatever we do from computing perspective has to be high performing. And that's what we have been delivering. So maybe on-prem, maybe on cloud, we are doing extremely well on this. And this is a phenomenal performing instance that you can look at for any of your graphic or HPC related applications, right?
So Sanjeev, I got to say, you know, when you said undisputed leader in HPC, absolutely. I mean, like at Intel, you know, the HPC leader is constantly wringing his hands over competing against AMD, you know, on-prem. And now that, you know, AMD has moved that architecture into the cloud, you know, we're starting to see some HPC workloads, quite a few HPC workloads, right, move to the cloud. We're working right now on a GROMAX and a LAMPS, you know, type of benchmark, and it's performing just amazingly well on the AMD HPC instances versus the competition. So HPC definitely should be landing on AMD. It was purpose built for that, and now that it's in the cloud, killer.
Yeah,
killer.
I just love to add some numbers, but so let me add with you. 2020 we delivered about 20 odd supercomputers. 2021 we delivered 73. So you can imagine the scale at which the adoption is happening about supercomputers being delivered by AMD to the world for many, many mission critical applications across the globe. You talk about US, EMEA, China, APAC, India as well. Right? So there's so much that's happening on that space, right? And of course, the benefits that we spoke about, the better performance, you have a choice of instances that's available with AWS, leverage. We are happy to help you, guide you from and leverage our resources available to help you optimize and choose the right instances as we go forward, right? So, you know, make it epic. You know, the AMD on cloud is epic, so just leverage that. With that, I would want to call you know, Tapan from MNex on the stage. Welcome, Tapan. We'll share some insights about some of the experience and some of the great work that they are doing in the agri-tech space. Let me not take the thunder. Why don't you introduce yourself and talk more about what you do, what space you work on, and how, you know, and scale at which you are doing, and how you're leveraging AWS cloud to build up that solutions. And, you know, they have done some massive, massive projects, right? So, Tapan, over to you. Please introduce yourself, company, and do run us through about, you know, a couple of case study solutions that you have delivered to the country.
Yeah. Sanjeev, John, thank you for having me here. Good morning, everyone. I represent a company called MNex Infotechnology, and we primarily working on AgTech sector, urban solutions, and the mining solutions. And to provide solutions to starting from the farmers to the ecosystem to the citizens at a large, we utilize technology of remote sensing, IoT, data science, everything put together, and because end customer is desired to have a solution, so they are not bothered about which technology you use. And obviously all this technology ride on cloud technology at my backend. So just to give you a perspective, we have been working with state governments and central governments alike, with the private sector and the ecosystem in the agriculture sector. Within agriculture, our main focus is till the harvesting. There have been number of solutions post harvest, but we have understood that there is a huge challenge in terms of providing techniques, providing technology, providing information right away to the farmers at the ground. That's a huge challenge. So we are trying to thrive. We are thriving to work on that. As we speak, we have been working with close to 25 plus cities of India, cities and state, providing various urban solutions, starting from public transport to smart cities to adaptive traffic, wherein we try to utilize the existing capability and generating more throughput, creating secure and safe environment for the citizens. And the third vertical of mine is typically working on the resources and utility side, and that's where we are trying to generate sustainable mining activity. We are trying to bring technology in very toxic environment, very difficult environment on the ground while the mining is happening. So that's all we do in nutshell.
Sure. And I think there's a lot of data that you do, right? Including leveraging drone as a technology to capture images. You do a lot of work with satellite images as well. Work on with an AI ML workloads at the back end to build up this entire thing. So can you share some more lights around
so
that?
let me take a couple of cases.
Yeah.
Let me start with an interesting agri use case. So we have been working with a few state government. Let me take example of my home state, which is state of Gujarat. State of Gujarat has got around 200,000 square kilometer of the area. More than 60% of that is agriculturable area. The challenge with the state of Gujarat is, and not only the Gujarat, let me again put down the perspective. We have been talking a lot about climate change. We have been talking a lot about climate resilient agriculture, and that's now reality, right? Consider a case, something flash flood happening in the Pakistan. A complete one season of crop has been almost diminished, and this is becoming reality. So how to at least try to cope up with such conditions. On the other side, world is also anticipating and watching many geopolitical equations getting changed. So with both of these things, food security is now reality, and every country globally is now talking about this. So how to have sustainable agriculture, how to have enough of the food grain reaching to the last person, that's going to be a big challenge, right? And that's not only now a question of economy, that's a question of strategy and a national interest. So states and centers have started thinking about addressing this issue. On the other side, farming and agriculture is one of the most complex areas, at least in countries like India. More than 60% of our population attached to farming as a livelihood, right? How to reach right information to each of them. How to get right information to all the ecosystem partner, be it the fertilizer provider or the seed provider or banks or insurance, any one of them, right? And that's where we try to provide a bridge. What we do in agriculture is using good amount of satellite images, using drones. We try to actually map each and every farm. So state like Gujarat, I'm talking about 15 million odd farmers and equal number of farms. So trying to put an eye on all of these 15 million farms day in and day out, trying to predict what crop is getting generated, how they are getting generated, what should have been, or what should the input could have been, right? And comparing this ground reality with the theoretical knowledge of agriculture and trying to identify gap. Having done that, providing right information to the right person at the right time. And that's what we are trying to achieve using various technology. And needless to say, all these activity has been backed by AWS as cloud, and we are happy to inform that we are one of the early users of AMD as a technology. So since 2020, we have been using AWS for such solutions.
Thank you so much. But can you share a little more insights on the scale of the data that you're using? And a lot of time people will feel that, oh, I have so much of data, will it work? Right? Because it's so dispersed, you're collecting data through IoT, getting that space, and how that has really, the cloud adoption has actually made it easier. And and the size of data that you manage, not on a daily basis, but probably on every minute or hourly basis, right? So maybe some insights there.
So because we have been using huge amount of visual data, which are the satellite images, drones, and obviously the ground data and IoT data. These data are predominantly very heavy, and not only a single use. We get satellite image for number of satellites, and that image has been analyzed number of times in a day. Like there have been sequence of pipeline. There is an ML pipeline happening, right? The moment I download an image from various satellite sources, there would be at least 20 different operations happening on that. And all these operations are not only resource consuming, also having huge amount of data as a back, right? On the other side, we need to generate the information almost in a real time. I need to reach to the farmer, I need to reach to the government almost every day. I need to reach because some climatic change, some weather information, some market information, right, has to be almost real in time. So just trying to put down in numbers, almost every season we have been generating in the tunes of 5 TB of data, and just not the data, reusing that data time and again. And that's the architecting which we have been using. with better architect, with better processing power, we have been able to reduce redundant usage of same images or redundant usage of same data.
Okay.
So it's just not the volume, but also performance and architect on that.
Okay.
So it sounds like you have a wonderful solution, great use cases, and it's great you're using AMD. Can you say a little bit more about the value of AMD? What has it brought to your solution?
Yeah,
what do you see in that technology?
So John, while we are trying to reach out to the huge customer base, and particularly the farmer. In India, farmers are typically not in position to invest in the technology or not actually in the position to invest in the information, and that's where the governments and ecosystem partners come into picture. And predominantly these industries quite cost savvy, right?
Cost is
cost savvy is very, very much important. On the other side, we need not compromise with the reliability, performances, security, as well as scalability.
Right.
And I think I'm happy to say that without compromising on any of these aspects, we have been able to achieve our cost reduction criteria, and that benefit is actually getting passed to huge number of users on the ground.
Oh, that's great. Yeah. Who need it? Yeah.
Yeah. And you're doing a lot of work on the smart lighting as well, right?
Correct.
And there's a lot of work you do on the transportation side as well, right? Correct. So maybe a little bit around that
Sure.
space as well as to what you're doing, and again how this whole what technology that you use at the back end that's helping you to deliver what you projects that you have already executed.
Absolutely. So many of us are aware about smart city missions. Like Indian government has come up with an idea that making many of our cities smarter, right? Now what is the meaning of getting cities smarter is actually making infrastructure digital, making this infrastructure reachable to citizen at a large, and making a governance which is deliverable online, right? That's the aspect. And with that aspect, very interesting use cases of public transportation, interesting use case of smart street light, as well as adaptive traffic control system, which we have been doing. So in the public transport, at the back, let's say we travel in Delhi, so we have DTC buses, or in Mumbai we have BST, or in Bangalore we have BMTC, and similarly metro. How to actually cohesively integrate various public transport services so as to have commuter should have an ease in terms of getting the information, in terms of paying for his travel, in terms of getting real-time updates about his planned journey, and that's what we are trying to achieve on the ground. And as we speak, we have been, as I said, we have been working with close to 25 cities providing such services. Coming to the lighting part, every city has got in the tunes of, like city like Mumbai has got close to 10 lakh of lights, the street lights, right? City of Bangalore has got more than 8 lakh street lights, and they are one of the biggest consumer of the power. Now India is getting converted from traditional street light to LED street light, and LED street light has a possibility to put down an extra IoT sensor on top of that. Now just consider a case that if I can switch off the street light early in the morning, and if I even can save 10 or 15 minutes of power. See, many a times these operations happens manually. The electric person go each and every zone, switch on, switch off. This is automated. In addition to this, street light brings a sense of security, a sense of reliability on the ground. A citizen would come out in the night if they have that street light on, right? And that adds up to your economical activity, right? But we have learned that maintenance of this street light is a big challenge. Consider 10 lakh of a street light. How do we know that which light is off, which light is on, and which to be maintained? This control will also bring an additional benefit. A command control center can actually not only monitor but also control as well as operate individual street light, can identify which one is faulty, can identify which could be the fault, right? And at the end, it's a huge, massive, in the tunes of 30% of power saving, at least 30% of power saving, which we have been achieving, right? The third use case, maybe very early use cases, we talk about adaptive traffic control system, right? In typical cities, we have very fixed cycle of traffic. If I am at a cross junction, there will be, let's say, 150 second cycle, 30 second, 30 second, 40 second, 30 second, depending on traditional traffic happening, right? But what we have learned is the traffic is very dynamic in nature, not only hour in the day, but also day in the week, as well as what day particularly in month or year you are traveling. And That too, historically it keeps on changing, right? Over here we have brought a solution using sensors which actually identifies traffic right away at a cross junctions and try to optimize the cycle right away over there. So that's where we have to bring edge computation on the ground. Having said that, one junction operation is not only enough, right? Ultimately we need to operate a complete network. So impact of one junction would be obviously how it's going to impact the complete network. And that's where the complex algorithms of machine learning comes into picture, and we try to optimize so that the same amount of road as a infrastructure can operate maximum amount of vehicle and reducing wait time. So in few of our use cases, we already have started observing in the tunes of 20 to 25% reduction in wait time with increased vehicle load with the same amount of road infrastructure. So coming back to the cloud part, cloud is actually enabling all these innovative use case, because now we need not worry about our backend infrastructure. We have to focus on the IoT, we have to focus on the end user, try to understand that business problem, try to understand and try to solve that problem. All my infrastructure related issues, like at least one of my pain area or one of my attention area has been amply being taken care of my cloud partners. So that's how, and in addition to this is highly scalable.
Okay.
So I need not actually keep on investing on bits and pieces. My complete focus goes on to solutions and the sales.
Okay. Thank you so much for that. I think we just have few seconds left. Anybody has any questions for us? Yes, please.
So I have now a startup at IIT Delhi. We work in machine learning, AI areas, and previously I worked for about 40 years in the IT industry. So I have two questions related to two separate verticals. One is on the vision products that we have, computer vision. So some of our products are based on OpenVINO, Intel OpenVINO.
Yes.
And we've tried to create through CX freeze objects and executables.
Yeah.
But Intel claims to run it only on Intel processors. So is there any way of porting them to AMD? The story on performance and cost saving per unit is very, very attractive for our customers.
Yeah.
So that's my first question.
No, the OpenVINO is good technology, but at Intel, at AMD, we have a technology called 1DNN. I'm starting to get familiar with all of the different libraries that AMD has to offer in computer vision, machine learning, deep learning, et cetera. So I'd love to take that offline and do a little more research to get you what the correspond, because I had that in my mind as well. It's like, wow, you know, how can we deliver an OpenVINO-like experience on AMD? Yeah.
So my second question is on the deep learning, predictive analytics areas. We did a very large program for a large auto manufacturer where we are running about 4 terabytes of data on the processor every month. So the configuration that we chose at that time had a 96 core CPU and 8 GPUs. But the GPUs were Tesla GPUs, so they either give Tesla or NVIDIA. So I heard you say that you have now GPUs. The built-in GPUs are probably not as powerful to run that kind of data. So is there any plan to have a single stack or single?
Are you doing training or inferencing?
It's for training.
Yeah, training, the GPU is still pretty good, yeah. But in terms of...
After training you can run the models
then you do the inferencing, you do the updates.
Any server
or
downscale it or anywhere else. So that's my other question.
So if I heard you correctly, we have the CPU, we have the GPUs as well. We have the MI Radeon Instinct, which are the data center GPU equivalent to what you look at it in NVIDIA or the Tesla cards. We are the first one to cross the exascale there as well. We go up to 11.6 versus less than 10 teraflop on that space, right? So we are building up on that, and strong open source libraries available to support the combination of CPU and GPUs, right? The frontier that I mentioned earlier is combination of AMD CPU and AMD GPU both. So if you build that up and we are building up, scaling up from that perspective. But as John said, we'd probably like to understand more, take it offline and see how we can help you on that perspective. But you know, any areas of special and high computing and some of these space, we definitely you know, would be the right choice, if I may say that.
So the economics is very powerful. So
Yeah,
absolutely.
economics is
Technically
powerful,
what we
yes.
want to
Yeah,
achieve.
The GPUs are still very expensive in the
And,
cloud.
and it scales up, right, while in the cloud environment, but just look at it scaling up to 64 core on a single socket. If you're talking about dual socket, you go up to 128 core. You probably need 3 servers to achieve 128 core, right? So you straight away reducing 30% or more on your infrastructure, right? We're going to scale to 96 and 128 core as we go forward. So your density optimization that you can get, both in terms of dollar per core or performance per watt, is going to be a phenomenal advantage there as well, right? So there's a great story in terms of what we are doing, and I'm not really even talking about the intangible benefits that you get, the power savings, the management cost of, you know, lesser number of servers, the licensing cost, the network ports, number of ports that utilization that happens because you're reducing number of servers that you need. So, you know, end to end, there is tremendous amount of advantages that we are bringing to the world today.
So thank you, Sanjeev. We'll take it offline, but
Sure, yeah.
the economics is very, very powerful.
Absolutely. Thank you so much. Thank you. All right, I think time's up. Sorry, if there's any question, we are here. Happy to take that up, happy to engage. Would love to hear more about what your needs are. If there's any challenges, issues, or anything that you want to help solve, we are there to have a conversation and look forward to that. Yeah. Right? Thank you so much, everyone, for your time, and thanks for a patient hearing. Thank you.
Thank you.